And for this deep dive, we're looking at something super important for, well, how the internet actually works day to day.
Right. How websites handle tons of traffic, stay secure, keep things running smoothly.
And the source material you sent us for this one was actually presented as a YouTube video. So our aim here is really to reinforce those ideas for you, maybe talk them through in a slightly different way to help it all sink in.
Makes sense. We're focusing on proxies, reverse proxies, and load balancers. These are the sort of invisible workhorses behind the scenes when you're browsing online.
Totally. I mean, how do the huge sites, the Googles, the Facebooks, the Amazons, how do they handle millions of people hitting them all at once and keep your data safe
Yeah.
and, get your click to the right server out of maybe thousands?
Well, these components are the answer, or at least a big part of it. So we're going to break down what they are, compare them, and really explain why they're so essential, sticking just to what was in that source video you shared.
Okay, sounds good. So where do we start? The source mentioned a core idea.
Yeah, the fundamental concept is this idea of a middleman, something sitting between two communicating parties.
A middleman. Okay. And the first type the video brought up was the proxy, or forward proxy specifically.
Exactly, the forward proxy. And the analogy used, which I thought was pretty good, is like having a personal assistant make a dinner reservation for you.
Okay, how does that work?
Well, think about it. That's your laptop. Maybe
Yeah.
on your company's private network, you don't call the restaurant directly. The restaurant is like the public internet, the website you want to reach.
Right.
Instead, your assistant, that's the forward proxy server, makes the call for you. So the restaurant, the website out there, only ever talks to your assistant, the proxy. It never interacts directly with you or sees your specific machine's identity on the internal network.
Okay, so the main point there is protection. Protecting the person making the request or their network.
Precisely. It's about protecting the private network, the client side. It acts like a shield. Think about a company where employees are browsing the web. All their outgoing traffic goes through this forward proxy.
And that proxy can then, what, filter stuff?
Yeah.
Like block access to certain websites the company doesn't want people visiting?
Yep, exactly. It can maintain blacklists or whitelists. And it can also scan things coming back, downloads, web pages for, viruses or malicious code from maybe shady websites before it hits the employee's actual computer.
So it's like a security checkpoint for outgoing traffic.
That's a great way to put it. The source also mentioned a couple of other things it can do. Logging user activity was one, so admins can see what sites are being accessed. And caching, this was a key one too.
Right. The video example was an engineer watching a tutorial.
Yeah. If one person in the office streams a specific, say, training video, the forward proxy can save a copy of it locally.
Right.
Then, if another engineer or 10 others want to watch that same video, the proxy just hands them the cached copy it already has.
So it doesn't have to go out to the internet and download it again and again.
Exactly. Saves a ton of bandwidth, makes access way faster for popular stuff within that network. So that's the forward proxy. Shields the client, filters outgoing stuff, speeds things up with caching.
Got it. Okay, so that covers protecting us, the users, the client side. But what about the other end? The websites themselves. How do they handle, millions of us trying to connect to them?
Right. Good transition. That's where the reverse proxy comes in. The source used another analogy here. If the forward proxy was your assistant getting you to the restaurant, the reverse proxy is like the receptionist at the restaurant.
A receptionist?
Yeah.
Okay.
Yeah.
How so?
Well, the receptionist stands at the front, right, in front of all the different dining areas. Those are the actual web servers holding the website content. The receptionist manages all the incoming guests. Those are the requests from users like you.
Okay, so the reverse proxy sits in front of the web servers.
Exactly. It receives all the incoming connections from the internet and decides which specific server behind it should handle that request.
And its main job then is protecting the servers. Because the source mentioned, it's risky to just expose all your servers directly online.
Hugely risky. Imagine having hundreds, maybe thousands of servers. If they're all directly accessible, that's a massive attack surface. It's much, much safer to put just one or maybe a few reverse proxies out front as the only entry point.
And that reverse proxy handles the security.
Yeah, it becomes the main security checkpoint for incoming traffic. It can scan requests for malicious patterns, make sure everyone's using a secure HTTPS connection, that SSL TLS stuff, check for hacking attempts, DDoS attacks, all that, before the request even gets near the actual application servers.
Okay, so it sounds like it has some similar features to the forward proxy, like the source mentioned caching again and logging.
It does, yeah. Caching responses from the servers can massively speed things up for users, just like on the client side. And logging requests is crucial for troubleshooting server issues, but the key difference is the direction and purpose. Forward protects clients going out, reverse protects servers handling incoming traffic.
Gotcha. And the source highlighted a really critical function that reverse proxies often handle, load balancing.
Ah, yes, load balancing, super important. This is the receptionist's job of not sending all the guests to the same dining area, right?
Right, you don't want one server totally swamped while others are empty.
Exactly. The reverse proxy distributes the incoming requests evenly, or based on certain rules, across all the healthy servers available behind it. Ensures better performance, reliability, stops things from falling over under heavy load. Nginx was mentioned as a really popular technology that does this.
Okay, Nginx, yeah. Now, this is where the source brought up a really interesting point, almost like anticipating a question someone might have. If reverse proxies like Nginx do load balancing, then why do cloud providers like AWS or Google Cloud offer separate things called cloud load balancers? Are they just replacements?
Yeah, that's a common point of confusion, and the answer presented in the material is no, they're not necessarily replacements. In fact, in big series setups, you often use both. It's a layered approach.
Both. How does that work? You have a load balancer balancing load to another load balancer.
Sort of. Think of it like layers of security and traffic management. You might have the cloud load balancer sitting right at the edge, the very first thing that traffic from the internet hits. It's outside your main server network.
Okay, the outer layer.
Right. It does some basic load balancing and maybe absorbs some large-scale attacks. Then it forwards the traffic to your reverse proxy, which lives inside your private network, closer to your actual application servers.
Ah, okay. So the Cloud One handles the rough initial distribution, and the reverse proxy handles things internally.
Exactly. And the reason for this layering, besides extra security, is that the reverse proxy, being closer to the application, can often do much smarter load balancing.
Smarter. How?
Well, a cloud load balancer might just use a simple rule like send the request to the server that currently has the fewest connections. Pretty basic.
All right.
But a reverse proxy, like Nginx, can look deeper into the request itself. It can make decisions based on things like HTTP headers or cookies or session information.
So, for example, it can make sure that my requests always go back to the same server I started my shopping cart on.
Precisely. That's called session stickiness or session persistence. If the application needs you to stay on the same server for your whole session, the reverse proxy can read a session cookie and route you correctly every time.
And the source mentioned something about SSL/TLS termination playing a role here.
Yes. The reverse proxy can be set up to handle the encryption-decryption part of the secure connection.
It decrypts the traffic.
It can, yes. By decrypting the HTTPS traffic there, it can actually read the request details, like the URL path someone is asking for, or those headers and cookies we mentioned, and make much more intelligent routing decisions based on that content. An external load balancer might just see encrypted traffic and not have that visibility.
Okay, that makes a lot of sense. And that sounds really useful for things like microservices, where different parts of the URL need to go to different back-end services.
Absolutely spot on. That's a prime use case. The reverse proxy can look at the path, like EP users versus AP orders, and route the request to the completely separate microservice responsible for handling users or orders. It acts as a smart traffic cop inside your application architecture.
So back to the restaurant analogy, the receptionist, the reverse proxy, isn't just filling seats. They know the regulars session data, maybe seat people differently based on a special request, headers, or direct people asking for drinks to the bar area, URL path routing.
That's a perfect extension of the analogy, yeah. Much more nuanced control. The source even gave a specific example, Kubernetes.
Right, Kubernetes clusters.
You often have an external cloud load balancer getting traffic into the cluster, and then inside you have something called an ingress controller, which is essentially acting as a sophisticated reverse proxy, routing traffic to the correct services and pods within the cluster based on rules you define. It's that layered approach in action.
Okay, wow. So forward proxy protects the client, reverse proxy protects the servers, and does smart load balancing, often layered with cloud load balancers.
Got it.
There was one last piece the source material touched on.
Yes. The question about those proxies that sometimes seem to start up automatically when you're just running code during development, like with Node.js or maybe a Java app, what are those about?
Yeah, are they the same thing?
The source explained these are generally much more lightweight proxies. It made the point that Node.js itself, for instance, doesn't have a built-in production-grade reverse proxy like Nginx, but you can build simpler proxy functionalities using its basic HTTP module or frameworks like express.js, often for development purposes or specific simple tasks.
Okay, and that led to comparing Nginx and Express.js.
Right. The comparison was basically Nginx is this battle-hardened, high-performance web server and reverse proxy. It's incredibly good at serving static files like images, CSS, handling tons of simultaneous connections efficiently, doing robust load balancing, managing security like SSL. It's really built for production deployment.
Whereas Express.js?
Express.js is a framework for building web applications and APIs in Node.js. It's great for writing the actual dynamic logic of your application, defining routes, middleware, connecting to databases, but as the source pointed out, it's generally not as performant as Nginx at just, say, serving static files or handling a massive flood of raw connections.
So they're used for different jobs, essentially.
Exactly, which is why a very common production pattern, as described in the source, is to use both together. You put Nginx in front of your Node.js application, that's running using express.js, perhaps. Nginx acts as the reverse proxy. It handles the incoming connections, serves all the static files super fast, deals with the SSL and decryption, does the load balancing if you have multiple node instances.
And then it just passes the requests that need dynamic processing.
Passes those specific requests back to the express.js application to handle the business logic. This lets each tool do what it does best. Nginx handles the raw traffic and static stuff. Express handles the dynamic application code.
Okay, that makes a lot of sense. It's like teamwork. So, all right, let's try and pull this all together then, based on the source material you shared.
Sounds good. So we started with the core idea, the middleman. We saw the forward proxy sitting in front of you, the client, protecting your network, filtering, caching outgoing stuff.
Right, like the personal assistant.
Mm-hmm.
Then we flipped it to the reverse proxy.
Yep, sitting in front of the servers, protecting them, handling incoming security, and crucially, performing load balancing, distributing requests, like the restaurant receptionist.
And we saw that load balancing can be simple or much smarter using the reverse proxy's ability to inspect traffic, leading to layered setups with cloud load balancers for, really big, robust systems.
Exactly. Understanding session stickiness, path-based routing, SSL termination, those advanced features of a reverse proxy are key there.
And finally, we touched on how even in development you encounter proxies, but production systems often rely on dedicated high-performance reverse proxies like Nginx, working with application frameworks like express.js.
Yeah, understanding these distinctions and how they collaborate is really, really fundamental if you want to grasp how modern websites actually scale up, stay secure, and deliver content efficiently. It's the hidden infrastructure.
Absolutely. So hopefully this deep dive, really focusing on the material you brought to us from that YouTube video, has helped clarify these concepts for you, maybe reinforce the key differences and how they all fit together.
And, the source material itself actually mentioned this, the importance of continuing to learn about these tech concepts, and also how supporting the channels or creators who make this kind of content clear and accessible, well, it helps them keep doing it.
That's a really great point to echo. Since we're here talking through the concepts from that source video, trying to help you lock them in, it feels right to pass on their message too. If you found this kind of breakdown useful, if you appreciate getting complex stuff explained simply,
Then the source encouraged you to engage with their channel directly. Subscribe, like the video, maybe leave a comment. Apparently that really helps them reach more people and keep creating good learning material like the one we based this discussion on.
definitely worth doing if you found it valuable.
Oh, and one more thing from the source, they mentioned having a free PDF resource, something about demo projects, maybe linked to a DevOps program they run. If you're looking to get hands-on and apply these ideas, the source suggested looking out for links to things like that could be useful for taking the next step.
Excellent. Okay, so we've covered a lot of ground proxies, forward and reverse, load balancing, basic and smart, how they protect clients and servers and enable massive scale online. Let's leave you with a final thought to chew on, kind of building on these ideas from the source. We focus heavily on web traffic, right? Web servers, websites. But think about the core principles here, using a middleman for security, managing incoming requests intelligently, distributing load efficiently. Where else might these fundamental ideas apply? What other kinds of distributed systems or services, beyond just websites, could benefit from these proxy or load balancing concepts? What examples jump out to you?